Large language models often exhibit a structural gap between baseline capability and real-world task realization. The DeepSeek V4 x J-Space Capability Realization Report addresses this exact issue. By applying J-Space version 3.7 to DeepSeek V4 Flash Vision EXP, this evaluation demonstrates how targeted cognitive integration minimizes execution loss across complex terminal, coding, and reasoning benchmarks.
The repository presents an empirical A/B evaluation measuring accuracy gains alongside wall clock time reductions. Using identical sampling parameters, model parameters, and environment isolation, the only dynamic variable toggled is the J-Space integration layer. The benchmark suite focuses on authoritative technical subsets including Terminal Bench 2.1, DeepSWE, Tolaflon Verified, and Automation Bench. The evaluation pipeline couples the base model directly with the standard mode DeepSeek harness. Incoming requests flow into the J-Space Cognition Suite version 3.7 dynamic wrapper before reaching the execution harness. This setup isolates prompt formatting overhead from true reasoning speedup, guaranteeing that downstream tools like shell interpreters and code environments interact under equal sampling dynamics.
Unlike evaluations that focus strictly on accuracy metrics, this report uses a two-factor measurement system tracking both task completion rates and wall clock tau metrics. Measuring elapsed clock time against output token counts exposes how structural context management alters generation density without altering model weights. Examining accuracy metrics shows noticeable improvement across task domains. Terminal Bench 2.1 score increases from 83.9 to 85.5%. DeepSWE rises from 59.3 to 61.8%, covering TypeScript, Python, Go, JavaScript, and Rust challenges. CyberGym improves from 75.3 to 77.8%, and NL2 repo pushes from 57.7 to 60.4%. Across all shared benchmark categories, the average score increases from 56.99% to 58.61%. On Automation Bench, performance improves from 25.7 to 27.6%, while Tolaflon Verified reaches 77.4% compared to the 75.9 baseline. Wall clock speed metrics reveal significant operational efficiencies. On Automation Bench, elapsed execution time drops to a tau of 0.76, yielding a 32% speedup while cutting generated output tokens by 31%. This produces a unit time score multiplier of 1.41x and drops per successful task costs by 12%. Similar patterns occur in coding and terminal environments. Terminal Bench 2.1 achieves a 27% speedup with a 28% reduction in output tokens, raising the unit time score to 1.29x. DeepSWE reflects a 28% speedup with output token savings of 28%, achieving a 1.34x unit time score.
Comparing the aggregate 58.61 score against major frontier architectures contextualizes where DeepSeek V4 with J-Space sits in the ecosystem. It surpasses Opus 4.8 at 58.33, while closing ground toward Kimi K3 at 60.96, Fable 5 at 62.13, and GLM 5.3 at 64.54. Analyzing output token compression explains how these latency reductions occur without sacrificing performance. J-Space structures context to reduce repetitive intermediate reasoning paths, decreasing output token counts by 22 to 31% in multi-step tool workflows like HLE with tools and Tolaflon. To replicate these metrics locally, clone the report repository alongside the companion J-Space Cognition Suite version 3.7 repository. Execute the standard harness script with the J-Space toggle parameter enabled, targeting the specific evaluation subsets documented in the repository configuration files.
A critical technical trade-off appears in single-turn tasks without tools. On Standard Humanities last exam without tool integration, wall clock time increased by 2% with a tau of 1.02, dropping unit time score to 0.98x. Injecting cognitive skill frames on single-turn operations incurs net overhead without multi-turn token acceleration benefits. The DeepSeek V4 x J-Space Capability Realization Report demonstrates that model execution loss can be systematically recovered using structured cognitive context management. By accelerating wall clock response times while raising pass rates across complex software engineering environments, J-Space provides an actionable model for frontier evaluation optimization.